All right, so a little bit about myself. I just left that slide there so you can connect with me later on. I'm not going to keep talking about what I do or what I'm passionate at. I do work at Shutterstock Custom. I'm a senior dev over there. So if you'd like to know a little bit more about what we do, feel free to come up and ask me. The slides will be shared later on, so there are links to everything in here. Okay, so let's get started. Most of us work with databases if we are technical. Who here works with relational databases on a day-to-day basis? Awesome, great. So we can kind of split databases, at least at a high level, into three categories. We have relational databases, things like Postgres, MySQL. We have document-oriented databases, Mongo, CouchDB. And then more recently, something that is becoming more common, it's not new, but it's becoming more common, is graph databases. And one example of a graph database is Neo4j. So this is one use case of graph databases, and that's the use case that we're going to be focusing on today. So just a little bit of a difference discussion between relational databases and graph databases goes as follows. In a relational database, if I wanted to connect people and departments, which is to say, I want a person to belong to many departments, and I want a department to have many people, I would have to have a through table. So I'd already be at 3 tables, and I would have to have that many-to-many relationships, or I'd have to have those tables to hit that many-to-many relationship. Now, in a graph database, it's a little bit different. In a graph database, you don't really have this concept of a through table. You have nodes, which are your entities. So for example, here you have a person node, and Alice is one instance of this person node. And then you have, on the other side, these department nodes, and you have many instances of those department nodes. And then the connection between those two nodes becomes a relationship. Now in graph databases, this idea of relationship is not new, but the difference is that it's first class, which means that everything that you do has to somehow touch on these relationships. You work with nodes, and relationships, these are the two main concepts that you're working with. And both of these have properties. So if you want to be able to store data about Alice, you can have properties inside of that node. If you want to be able to store data about a department, again, you can have properties inside of that node. The interesting thing is that relationships themselves also have properties. So if I want to say, for example, Alice belongs to that department, I can add a property called since, which is to say, when did Alice join that department? Which is the same thing that you do in a through table. You'd add more columns in a through table, but in this case, it makes it a little bit more intuitive, even for you to look at it. So these are the main things that we're dealing with, nodes and relationships. And then properties, which are data points about nodes or relationships. So this is kind of a compare and contrast between doing the same task in a relational database versus doing it in a graph database. In a relational database, if I wanted to connect person and project, I'd again have to have a through table. So you can already see how in a relational database, you end up with so many tables very, very quickly, especially if your data is highly related, which is most of the real life scenarios, right? Like most of the things that happen in real life are highly connected and they're highly interrelated. Now, that's where graph databases come in. You can see here that the design for a graph database is a little bit more intuitive, a little bit more natural for you to kind of look at it, immediately understand. And you don't lose any of the data. You still have the same amounts of data, but the difference is a person now can have connections to a department that are A-directional. So a person can be a part of a department, can work at a department, and then the other way around also works. So a department can be led by a person. One thing that is avoidable in Neo4j is you don't have to create the same relationship in two different directions. If you have the relationship going one way, then you can query without necessarily specifying the direction, and we're going to talk about that in more detail a little bit after. But at a first glance, you can already see how it simplifies your database design, which is to say that your real-life model is now a little bit closely related to what you're modeling in your database. So you don't have to kind of bend your mind and keep thinking about ways to represent your data in different ways. It can almost be just like the way that you represent it in real life. So the use case that we're going to be looking at today, or the example, is how do we recommend movies, right? Everybody wants to recommend movies, but how do we do it without building something that is complex? How do we do it in as few lines of code as we possibly can, and even something smaller than a relational database? So we're not talking machine learning, we're not talking anything that is taking those extra steps. We're just talking how do I search, or how do I solve the problem of search in a way that can be used for recommending new things, or for recommending new pieces of data. So this is going to be our domain model, a simplified domain model, where we have a person, and this person has a relationship to a movie by either reviewing it, or by acting in that movie, or by directing that movie, or by producing that movie. So these extra relationships I didn't draw up, but the other two are just actor, directed, and produced. But here we can see examples of acted in and reviewed. And then a movie can have a genre, so it's connected to a genre node. Anything that is a circle is a node, anything that is an arrow is a relationship. Okay? And then a person can also be related to other people, so other person nodes where they can be friends. If we wanted to do this in a relational database, again, we would have to have that extra table saying friendships and have the 2 foreign keys for each person. Okay? So this is going to be our domain model, very closely resembles what happens in real life. Now, we're going to dive a little bit into the actual code. First thing we're going to do is we're going to insert 1 movie, a few reviewers, and let's say a few genres. So we're going to keep the data set very, very small, just so we can understand what is happening with our database. So I'm going to copy all of this over, and I'm going to move over to a console that Neo4j ships out with, and this is where you can actually try out your code or your queries in real time. By the way, just a quick note, this language is called Cypher, or Cypher Query Language. This is what Neo4j uses in order to query its data or to create its data. The same way that you have SQL, you have CQL here. Same concept, slightly different. All right, so we can go into our editor here, and let's go a little bit deeper into the code that we're looking at. So at the very top, we can see here that we're creating a few data points, and each of these data points has a label. This label represents the type of node that you're creating. So in this case, I want to create 5 genres, and in each of them, I specify that I am creating a label genre. I'm creating a node that has this genre label, okay? And anything that is on the left side is basically just a variable that I've defined. So you can technically say genre 1. That would still work. This is a variable. You name it however which way you want to name it. I just called it these because I want to be able to reference them easily later. Okay? And then anything that goes in between the squiggly brackets or the object are basically the properties of this node. Name is just the basic property. You can add things like, for example, is popular. And this could be a boolean, true or false. So you can add properties to whatever node you're creating. It doesn't have to be very strict. So we have our genres over here. And then the next thing that we're doing is we are creating the movie. Same thing. We have a movie label. The matrix is just a variable that I came up with. So you can call this whatever you want. I just wanted to be able to refer to it easily. And then we have properties. Okay? So far, so good? Yeah? Excellent. Then we go ahead and we create a few people, right? So they each have the person tag. And the properties is just name and the date that they were born, fairly simple. And now what we're doing is we're creating a few more people, but with the intention of using those as reviewers later on. Technically speaking, you could have created a reviewer node, right? But there's no need for that because we can represent those as people because of our domain model. So if we look back at our domain model, we decided to use person as one type of node as opposed to splitting them up into 2 and having this idea of an actor and having this idea of a reviewer. There's no need for that. We can represent them all as person. And then as we query the relationships, we can start to deduce a little bit more information about who this person is. All right, so we've created those people, and this is where things get interesting, okay? This is where things become different from what you would otherwise see in a different database. This is how you create relationships in Neo4j. So all I'm doing here is I'm saying that reviewer 3 should have some sort of a connection to reviewer 4, reviewer 1 should have some sort of connection to reviewer 3, and so on and so forth. So I'm creating those friendships or those connections in between the reviewers. And I'll show you what those look like in just a second. I'll query them and I'll talk about how they are represented. And then finally, what we want to do is we want to create relationships to the movie itself. So we've created relationships between people and other people. Now what we want to do is we want to create relationships between people and the movie in the sense that did they direct it, did they produce the movie, did they review the movie, and so on and so forth. And you can almost read this as English, right? So you can say that we have this variable Keanu, which we've created at the top here. So we have this variable Keanu, and then we're saying that Keanu has acted in, this is the relationship definition, Keanu has acted in a movie, and these are the properties of the relationship itself. Okay, so in the same way that you would have a through table, and the through table would have properties, you're doing that in the relationship here. So let's quickly run this, and of course at the end we have some genres, so a movie has genre sci-fi, a movie has genre action. Okay, so let's go ahead and run this. And now what we get is kind of like a quick stats about what just happened. It created 17 nodes, 36 properties, so on and so forth. So now what we want to be able to do is we want to be able to match against what we just created. We want to be able to fetch what we just created. And what I'm going to do is the following. I'm going to say I want some variable P, which has a label person. This is how I search for a person. So I'm specifying that I want a node of label person, and I want this person to be connected or to be friends with some other person. And I can say P2, and then we have again another person here. So, and then what I want to return finally is I want to return the person, whoever they are, and their friends. Now, what this will do is this will actually return to me all of the people that are within my network that have this friendship concept or that have this friendship relationship. Okay, so let's go ahead and do that. And we can see here what we're getting back is the 4 reviewers that we've created along with the relationships that we've created them with. Now, if I click on any of those, you can see here that I have an ID for this specific relationship. This means that it can have more properties, right? So, for example, if I wanted to get a person who has acted in some movie M. Again, this M is just a variable that I'm making up. And what I want back is I want the person and the movie that they've acted in. And what I get back is the movie that I've just inserted as well as the actors that I've inserted for that movie. Now, where it gets interesting is that this movie itself has properties. You can see that at the bottom. So tagline, title, and things like that. And then the acted in also has properties such as roles. So what this allows you to do is you can say, give me some actor who has had this specific role in some movie without knowing what the movie is and without knowing who the actor is. And it will actually query your relationships and give you those dynamics. Okay, I'm going to keep going just for the sake of time. Let's see a slightly more difficult example. But before we do that, I quickly need to seed the database. So we'll just create about 10 movies. I'll just delete first what I just created. And then we're going to create about 10 movies. Some have reviews, some don't. I just prepared this before the talk. In reality, you could import from a CSV here directly. You could import from Mongo. So this has Spark connectors, this has Kafka connectors, whatever you need to connect to. You can actually connect directly to it and have it import into this representation. I'm just doing this as the simplest possible way or the simplest possible approach, okay? So let's go ahead and run this, and what we get here is created about 70 nodes, 212 properties, and a bunch of relationships. So now what I can do is I can ask deeper questions. I can ask, for example, show me a movie that I haven't reviewed yet, but my friends have reviewed, because that might be of interest to me. In the same way that Netflix recommends to you something that people of the same watching habits might have watched, but you haven't watched it yet. Okay? Of course, way more complex than Netflix. This is a super simplified version of what's going on. All right, so let's go to this, and this is where we can kind of understand a little bit about what's going on. So if we run this query, and I'll go through what it's doing line by line. If we look at this query, we can see here that we want to match for a person. We want to find a person, and we're going to label this colleague. Okay, again, the label doesn't matter, or the variable doesn't matter. I can call it C for all that matters. And then this person must have reviewed some movie M. Okay, notice the directionality in this relationship. If I did not know the direction, all I need to do is remove this arrowhead. And then it becomes agnostic. Whether it's going left to right or right to left, it doesn't matter. Right? But I know in this case what the direction is, so I'm just going to query it directly. And I want this person to have reviewed some movie M. At the same time, I want to get some person P to represent the current user. So I know who this user is, and this is going to be a representation of who I am. So pretend that I am currently the current logged in user is Sarah. Okay? And then finally, what I want is I want this colleague to be friends with me. Or I want this colleague to be friends with Sarah. So I've defined 3 restrictions here. I'm saying that the colleague should have reviewed the movie M, and then there's a person P who is representative of who I am. And then finally, those 2 people should be friends. So me and the colleague should be connected in some friendship. Okay? And then I can start specifying a where clause. So I can start searching for things. I can say that the colleague's name should not be my name. This is redundant, by the way. Because technically speaking, if I'm friends with somebody, I'm assuming that I shouldn't be friends with myself. But just to show you how the inequality works in Neo4j, you can specify it that way. And I also want to make sure that I have not reviewed that movie. So P is what I'm using for Sarah. I want to make sure that there should not be a reviewed relationship between me and the movie that I would like to be suggested. You guys with me so far?
So P minus means not.
Where do you see P minus?
Not. Oh, sorry, not.
This is just the relationship.
Sorry, never mind.
Yep. Cool.
Sorry.
And then finally, what we want to do is we want to return colleague, the movie, and me, right? And the only reason why I'm returning me here is because I want to visualize it in a graph. I'll show you in a bit how you get raw data just without the graph. So if we run this, what we get back is a few people, so Emily and Jane Doe have both reviewed The Matrix Revolution, and Jane Doe has reviewed The Devil's Advocate. But I haven't reviewed it. I don't have any relationship to any of those movies. Okay? In a real life scenario, of course, you get much more data. I'm just simplifying it so it's easy to visualize. So now we can automatically say, okay, well, these are two movies that we can recommend to Sarah because she has not reviewed them yet, but her colleagues have. And I did that in such a small query. So I want you to kind of like appreciate how small the query is and how kind of easy it is to write. It's almost like you can write it as you're thinking about it, which is I think, in my opinion, one of the biggest things about Neo4j is that their query language is so easy to use. You might get benefits like this, by the way, from using GraphQL or something like that. But in here, the data is actually represented as a graph. Whereas when using GraphQL, you don't have to represent your data as a graph. Okay? These could lead to very different performance results, but your query might look the same, or similar at least. Okay, so let's do something a little bit more challenging in the spirit of doing things that are interesting. So what if you want to answer the following question? What if you want to suggest movies that have been reviewed by colleagues that you haven't watched yet, but they should have an average rating of 4, minimum, and they should have some genre, either thriller or action. Now notice here, when I'm saying an average rating of 4, I mean from your colleagues, not from other people. So your colleagues should have liked it. Okay? And that's where it gets a little bit more complex, and this is what our query looks like. So let's see what we're getting here. So just like before, we have person who has reviewed the movie. The difference is, though, we're extending it a little bit now. We're saying that movie should also have a genre G. And you can go as long as you want. Like you can write the full representation of the graph right here in one line. I'm just choosing to break it up. You can also break it up. So you can say, if you wanted to, you can say, I don't want to specify the genre thing on the same line, so I'm going to go ahead, and I already have the reference to M, so I want M to have some genre G. These are equivalent. Okay? It's just nicer to be able to kind of write it in one go. All right? And then in our where clause, we have similar stuff to what we had in the past, but the difference is that we also want to be a little bit more specific about the genre that this movie is attached to. And then we have this thing called the with clause. This allows you to run aggregation functions. So things like count, sum, average, you can do it before returning. So you can do it in the middle of your query. So this, what it's doing over here is saying we want the average of the reviews. So we have a property here, rating, inside of each review. I'll actually close this really quickly to show it to you. So inside reviews, if you look at the bottom, you can see here that we have a property called rating. So each review relationship has a property called rating, and we can query by those values. So we can say that the rating, the average rating, is going to be labeled as average rating, as a variable that we have. And we also need to collect all the distinct colleagues' names. So in a scenario where we actually want to know who are those friends that have rated this movie, we can actually collect that data. We can collect those notes, or at least the names of those people that are with us, and we can label those as whatever variable we want to. And then finally, we want to do the same thing with genres. We want to collect the genres in an array of strings. And then what's beautiful here is that we can actually add another where clause. Once we've done the with, we can add another where clause where the average rating should be more than 4. In this case, we want to actually do our where on whatever aggregation we've done. Okay? And then finally, we return whatever data we need to return. And in this case, I'm not returning nodes, I'm returning the actual data itself, so we should be able to get it in tabular format. So we can see here that the movie title is called Devil's Advocate, average rating of my friends is 5, who is this friend is Jane Doe, and then what are the genres that matched up? It's a thriller. These are the genres that I like that matched up. Okay? If we reduce the average rating, of course we get more results. So in this case, we're getting more people who have rated The Matrix Revolutions, and then they gave it an average rating of 4. Okay? Now, let's actually do something a little bit even harder. I'm going to skip this one for now, just for the sake of sticking to the time. But let's say we are in a scenario where we want to suggest a movie that has an actor that acted in another movie that we've reviewed in the past. You gonna say that one more time? So let's say I like Jason Statham. He's acted in like 5 different movies that I really like, but he had like 10 movies in total. Okay? So I want to now be recommended this Jason Statham dude based on the fact that I've reviewed 5 of his movies in the past, but I haven't seen his other 5 movies. lines as I possibly can, as intuitively as I possibly can. Okay, this is where Neo4j becomes absolutely beautiful. So let's copy this into our search, and let's kind of quickly break it down line by line. So here at the very top, we said this is who we are. We're going to put that in a variable p. We are Sarah. Okay, and then we want to also find this person, which we're going to label A, or we're going to put in a variable A, representing actor. Okay, so we want to find this person, actor, who has acted in some movie that has been reviewed by me. Right? So what you're saying at this point is, I am a person, and I want to find this other person who has acted in movies that I've reviewed. And by the way, this could be many people. You're not looking for one person at this point, you're looking for many people. You're just representing it as a type person. And then finally, what I want to do is I want to find other movies that this person that I just found has acted in that I haven't seen yet. Okay? So here what we're saying is that this actor should have acted in some movie M2, and there should be some review by some person on this movie. And then in the where clause, you can say that person who has reviewed that movie should not be me. Okay? By the way, whenever you see me putting an object inside of the match clause, this is the same thing as putting it inside of the where clause. You're just choosing to put it in a different spot. So if I wanted to do this differently, I could have done something like p.name equals to Sarah J. And the two queries are equivalent. Okay? And then finally, what I want to return is I want to return the title of the movie, of each movie that this applies to. I want to return the average rating of that movie from everyone in this case. I'm not talking about colleagues at this point. And then finally, I also want to return the actors that exist in that movie. Okay? So if I run this now, what I get back is I get back the Devil's Advocate, the Matrix Revolutions, average rating for both of them, and then the actors that exist in that movie that I'm interested in. Okay? All right, so this is kind of, at a quick glance, this is what Neo4j enables you to do. And these are all base Neo4j features. You haven't started to extend it yet. So they have this thing, just before I finish up here, they have this thing called APOC, which stands for a package of components. Totally generic name. It also stands for this character that existed in some movie. There's a whole story behind it. I have links for the documentation. Go check it out. But basically what that does is it gives you a bunch of functionalities that you can inject into your query. So let's say we actually wanted to use NLP, right? Or we wanted to involve NLP, and we'll involve it at a high level, which is just sentiment analysis. I just want to understand what was the sentiment of my comments, and while doing that, I want to inject that into my results. I want to make that a part of my search. So what I can do in that case is I can do something like the following. I can say and, let's say APOC.NLP.sentiment, and this would be a function that you define, okay, that you define in any JVM language. As long as you can use a JVM language, you can plug it into here. So Java, Scala, any of these things would be okay. And then what you can do is you can say, okay, well, calculate the sentiment of movie2.comments. So if we had comments, of R2, which is review 2, so we can see that here at the top. So if reviews have comments, we can also say, well, give me the sentiment of the comment and make sure that the sentiment is at least more than 0. So somehow a positive sentiment about this movie. Okay, and you can make that, again, as a part of your results. You can order by that sentiment, and you can do anything that you would otherwise do. The only difference is now you've injected some component that allows you to do a calculation as a part of your search in real time while you're doing your search. And just to kind of give you a little bit of context, what this looks like without Neo4j is you either have to cache results, you have to cache distance results if you're doing something like Mongo, or you have to do really heavy queries if you're using something like a relational database. Either way, it's nowhere close to the ease that this was done with. Like you could do this in a day, basically. And it would work. By the way, it's also ACID compliant, so you get transactions and all these beautiful things. That's number one. And number two, it has drivers. So you can use Node.js to use it in the same way that you would use Postgres. You can use Scala to use it in the same way that you would use Postgres. It doesn't matter how you interact with it. The only limitation is that you need a JVM language to define custom methods inside of your search. That's the only restriction. Other than that, you can use even HTTP to interact with this. It has an HTTP client that ships with it. It also has like the community edition, which is the one that I'm using, versus the corporate edition. I won't go into those. I've left some links for you guys at the end of the slides. So if you're interested in learning about this, if you're interested in finding out courses or books or things like that, you can go check them out. They have a couple of courses on their own website, and they're quite useful. That's where I would start personally. And if you're more of a book reader, then they have some list of books that you can get started with. Any questions? Yes. Yeah.
Okay. When you were doing your aggregation, right? Were you selecting your data set before or after?
Okay, so you can do it either or. So first, the first thing you need to do. Yeah, of course. So the question was, when you are doing your aggregation, do you select your data set before or after the aggregation? So it's kind of a bit of both. The way that Neo4j works is you index it by the starting point of your search. So everything starts from a node, and that's your starting point for the search, and then you kind of explore the graph from that point onward. So that is important. You have to know where you're starting your node, and that's how you optimize your database. But also, given that you can use the with clauses for aggregation, you can add a where clause after the with clause that helps you filter those aggregations even further. So you can do both, is my answer. They, like, I won't go into that right now, but they have an analytics tool that helps you break down the performance of every query that you use. So I would basically look at that, and it just helps you look at how many DB hits it's doing, how much it's holding in memory. One gotcha here is that you should never search the entire graph at once because it holds the results in memory. So if you're searching huge data sets in one go, it's gonna crash. So what you do instead is you limit your searches. It has cursors the same way that any other database has, and I mean, this is general best practice. You should always be doing that, regardless what database you're using. But that's a one caveat: is if you're looking up like tens of millions of records and they're heavy, they have a lot of data, then it might actually crash. Also, another thing is to note is you index by where you're starting your search. So if you know that there's a specific starting point for your search, that's a good place to index. Like in my case, what I would have indexed is I would have indexed the name on person, because that's my starting point. Yeah. Yeah.
Great presentation, by the way.
Thank you.
In terms of performance, how does it compare for different operations in Neo4j database? Like insert, like what's the downside of some of the operations?
The inserts.
The inserts,
yeah. Because the lookups are fast. The lookups are, there's no problem there. Neo4j used to use a different database internally to store all this information. Now they use their own store that they came up with, so they've gone quite a bit in that sense. But the inserts, naturally, because you're inserting relationships and you're doing all these things, the inserts are slower than what you would get in a relational database.
Do you recommend like using another database for some sort of data and then just for this recommendation?
Yeah, so in Neo4j, the Mint use case is a recommendation engine, but it's not the only use case. They use it for like fraud circles and that kind of analysis. Any analysis where you have a network and you want to understand what is happening in your network, this is a good use case. But I do recommend using something else as the application database. However, just to be fair, it is capable of handling these things, in the sense that it gives you the safety net and the transactions that you would need. But my personal recommendation would be to use something for your application database and to use this to query intricate relationships in your data. Yeah. Okay.
You're talking about basically having a regular persistent storage database in the application.
Correct.
Somehow seeding this with whatever, and managing that data.
Exactly. Yeah, exactly. Like, I'll just give you an example. At work, what we're doing right now, or what we're looking into doing right now, is we want to extract the data out of whatever number of databases that we're using, put it into Spark, and then plug the data from Spark into this. So if you're using Spark, for example, you can use a Spark connector to work with Neo4j. If you're using Kafka, you can do the same thing. Actually, even if you're using Mongo, you can talk from this to Mongo directly. Okay, so whatever database you're using, I would use that as the application database, and then I would use this for the specific purposes that you have, which are usually more analytical. Yeah. Have I used GraphQL within MongoDB? I don't know why, but that sounds like not a great idea. Because I'll tell you why. Because I've tried to use MongoDB in a data set that was highly relational, obviously while taking the best practices and not thinking about it as a relational database. It still got me into trouble. So I think that like using something that is basically highly relational data and MongoDB don't go on. And that's my general rule of thumb. I haven't. The short answer is I haven't. Yeah.
that they implemented that
I mean, you could do that, but the amount of work that you'd have to go through just to get that kind of optimization is, I assure you, like hundreds of times larger than what it would take you to set this up. Any other questions? You good? Yeah.
Hey, just a quick, how do you scale, like, you know, for the backend, like, just one monolithic server?
You can put a cluster and you can have replicas. So that's one way to scale it. That option is only available in not in their community edition. It's only available in their enterprise edition. So you have to actually purchase something from them to get that going. But usually the simplest way would be to cluster it with replicas, and then you'd have some leader follower type setup. Yeah.
Can you speak to the advantage using Neo4j in contrast with using an adapter like Apollo to a relational database?
What was the second half of the question?
In contrast to using some sort of GraphQL adapter to
Yeah, they're very different things in the sense that, like, I can give you a comparison. It highly depends on your data and how you're implementing these things. But just like kind of a quick compare and contrast is with GraphQL, your data is not stored as a graph, or doesn't have to be stored as a graph. With this, the data itself is stored as a graph. What that means is if your data needs to do graph operations like centrality and that kind of things, you're better off in Neo4j. But if you're purely using it as a nicer way to query your data, then I would probably go with GraphQL. Because GraphQL just adds that querying layer on top of your data, whereas this represents your data entirely differently. If for example, you're trying to understand what is the connectivity of a certain influencer on a social media network, I would do that here. No problem. All right, guys, any other questions? Awesome. Thank you for listening. Cheers.